Hey everyone, and welcome to another Explainer. Today, we're literally rethinking everything we know about agriculture. We're taking a really deep dive into a concept that is actively transforming dry, degraded lands into lush, self-sustaining ecosystems. It's called the food-forest revolution. We're going to explore the mechanics, the deeply rooted history, and the massive economic and health benefits of natural farming food forests. As you'll see, moving away from chemical-heavy monoculture and returning to nature's original blueprint is creating serious wealth and health for farmers all over the world.
Welcome back. If you like what you see today, please subscribe, drop a like, and share this video with someone who'd love it.
Okay, let's dive into this. To really wrap our heads around modern natural farming, we actually have to hit the rewind button, thousands of years backward to be exact. What we call agroecology today is actually deeply rooted in Vriksha Ayurveda. Now, this is the ancient Indian Hindu science of plant life. In Hindu tradition, there's this really profound reverence for nature, and Vriksha Ayurveda actually outlines how humans can harmonize with the environment to cultivate what's called aranya, which essentially translates to a lush, self-sustaining forest ecosystem. It's a whole philosophy built on the idea that plants should cooperate with each other, not compete. So instead of trying to dominate the land, this ancient wisdom teaches us to just observe the natural succession of a forest and gently guide it to produce food. It's literally history providing us with a direct blueprint for modern survival. So here's our quick roadmap for today's explainer. We'll be looking at the 5-layer model, spacing and sunlight, rain-fed crops, health and economics, and finally community training.
All right, let's jump right into section 1, the 5-layer model.
Now, what's really interesting about this slide is, well, think about walking into a wild forest, right? You don't just see one type of plant sitting at one flat height. You see this amazing vertical stacking. We start way up at the top with the canopy layer, soaring 30 to 60 feet high. These are your heavy hitters. Think mango or coconut trees. They take 100% of the full sun and give you that long-term yield. Step down a bit and you hit the understory, 10 to 30 feet high. This is where pomegranates or guavas soak up the partial sun, filtering through that canopy. Below that is the shrub layer, 3 to 15 feet, which is packed with berries and nitrogen-fixing plants. Then we have the herbaceous layer, right at eye level and below, giving us perennial vegetables in the dappled light. And finally, down at your feet, the ground cover. This sits in heavy shade and acts as a living mulch to stabilize the soil temperature and choke out weeds. By stacking plants exactly like this, a food forest captures and maximizes every single photon of solar energy.
Moving on to section 2, spacing and sunlight.
Okay, so making this work relies on an incredibly precise mathematical strategy. Just visualize a 36 by 36 foot grid laid out on the ground. At the 4 corners of this square, you plant your primary canopy trees. Because they're spaced 36 feet apart, they have all the room they need to grow massive and capture that 100% sunlight. Then, exactly halfway between them, at 18-foot intervals, you plant your understory trees. They need less space, and they absolutely thrive on 50 to 70% sunlight. Halfway between those, at 9-foot intervals, go your shrubs. At 4.5 feet, your herbaceous crops. And whatever ground is left, that gets filled with creeping live mulch and root crops. Every single descending layer is spaced closer together specifically to capture the exact intensity of sunlight it needs to thrive. It's honestly like a stunning geometric puzzle where every piece perfectly supports the others. That brings us to section 3, rain-fed crops. This model is so incredibly resilient, even in regions that are completely dependent on seasonal rain. Take the mango grove dryland model, for instance. Look, when a smallholder farmer transitions to this system, they can't just sit around and wait 5 years for a mango tree to produce fruit, right? They need to feed their family today. So the farmer plants short-term crops like beans and dryland vegetables that yield in just 2 to 4 months. That provides immediate cash flow and food. By the time those finish up, the medium-term crops like banana and drumstick are ready in year 1 or 2. And all the while, those long-term canopy anchors, the mango and tamarind trees, are maturing in the background. It's a continuous, sustainable harvest that completely eliminates the massive financial risk of waiting on just one single crop to mature.
And in these rain-dependent zones, choosing the right species is literally a matter of survival. The food forest doesn't rely on some massive, expensive municipal irrigation setup. Instead, it relies entirely on biology. You choose plants with very specific drought-tolerant adaptations. Some plants escape the drought, like short-duration millets that just rush through their whole life cycle while the rainy season lasts. Some evade it, like fig trees that actually drop their leaves to stop moisture loss. Others endure, like olive trees that simply slow down their metabolism, or they resist by acting like succulents, storing water right in their own tissues. If you choose the right anchor species, the forest practically irrigates itself.
Let's look at Section 4, Health and Economics. While the ecology side of this is obviously super fascinating, for the farmer, this absolutely has to make sense for their wallet. Just look at this really sharp contrast. In conventional monoculture, farmers are so often trapped in a brutal cycle of debt. They face extremely high paid-out costs to buy synthetic fertilizers, chemical pesticides, and patented seeds year after year after year. But in a natural farming food forest, those costs plummet to nearly zero. The farmer uses on-farm biological inputs, things they already have lying around, like cow dung, cow urine, and fallen leaf biomass, to create these incredibly powerful micro-bridge fertilizers. Eliminating those external chemical costs radically reduces financial risk and just completely frees the small farmer from crushing debt. So the crucial point is, when you eliminate all of those super expensive chemical inputs and you combine that with the premium multi-crop harvests from the staggered layers we talked about earlier, what happens? Well, diversified natural farms actually see a 20 to 40% higher net income compared to conventional farms. That means way more money is staying directly in the farmer's pocket.
And the savings aren't just in chemicals either, because that ground cover layer acts like a living, breathing mulch. It shields the soil from the baking sun. And because those deep tree roots naturally hold water, these food forests result in a massive 50 to 60% savings in water and electricity requirements. The ecosystem is actually physically holding the moisture in the soil, which is a huge protection against severe groundwater depletion.
But you know, the wealth generated here isn't just financial, it's physical. Industrial agriculture has kind of simplified our diets down to just a few staple grains, and that's led to widespread malnutrition, or what experts call hidden hunger. Food forests completely flip the script on this by growing diverse, nutrient-dense foods literally right in the farmer's backyard. Studies have shown that this localized dietary diversity leads to an 18% reduction in vitamin A deficiency and a 15 to 20% reduction in childhood stunting. Plus, it acts as a seasonal ecological safety net. Even if a bad drought wipes out an annual grain crop, the deep-rooted trees and shrubs in the food forest are still going to produce fruits and nuts. And of course, the whole system totally eliminates toxic chemical residues from both the food and the local water supply. And this brilliantly illustrates exactly what we're talking about. Planting these dense, multi-layered tree systems does so much heavy lifting for the planet. It naturally absorbs carbon dioxide and pollutants from the air. The vast root networks prevent soil erosion and water runoff, while simultaneously creating a rich habitat that promotes incredible insect and animal biodiversity. The environmental and the nutritional benefits are just deeply, deeply intertwined. Finally, let's head into Section 5, Community Training. So we know the science works, right? But how do you actually get millions of farmers to change how they've farmed for decades? You empower the community. Local initiatives have deployed an astounding 33,676 community resource persons. These are highly trained locals who are taking this indigenous technical knowledge directly to the village level. Here's how that community expansion strategy actually functions on the ground. First, women leaders, known as Krishi Sakis, provide direct, village-level guidance. But what if a farmer wants to transition, but, say, doesn't own a cow to make their own biological fertilizers? Well, that is where Bio-Input Resource Centers, or BRCs, come in. These are local, cluster-level enterprises that supply ready-to-use biological inputs, like really rich, fermented microbial inoculants, directly to the farmers. They run on-farm demonstrations showing exactly how these natural inputs outperform chemical fertilizers. It just ensures that absolutely everyone, regardless of their immediate means, can successfully make this transition. And it's important to mention that this whole transition is supported by amazing grassroots organizations. That local institutional support, that's the real backbone of this movement. They help rapidly scale these 5-layer models, providing the education and the logistical support to turn individual farmer successes into widespread, robust community resilience. It's this beautiful, localized, self-sustaining loop of knowledge and resources. Which brings us to our final thought for today's explainer. Just look at the wild woods, the oldest ecosystems on our entire planet. If an ancient forest can endlessly feed the earth, build the soil, and perfectly manage water without a single drop of synthetic chemicals, isn't it time we step back and finally let nature do the farming? Thank you so much for joining me to explore this incredibly vital topic. Stay curious, and I'll catch you in the next explainer.